What is the leading theoretical model in science that explain how gait control is achieved in healthy brains and in brain of people with Parkinson's? First, in healthy individuals, gait automaticity is achieved via processing across different areas: dorsal, cortical, striatal, thalamocerebellar, brainstem, neural circuits. The segregation of the motor circuits from this order, the sensory, the limbic, the cognitive circuits, allow consecutive processing of multiple inputs without interference, ensuring normal gait automaticity. Note, however, that gait is not always automatically controlled. Attentional control will be called upon in gait during complex circumstances. The need for attentional gait control increases with, for example, age, or in people with Parkinson's disease, or if we walk on an uneven surface. Following then substantial degeneration of the nigrostriatal dopaminergic neurons, which in the graph is indicated by the gray coloring in the dorsal striatum, which is of course already prominent in early Parkinson, gait automatically becomes impaired. External sensory input and cognitive control comes on to maintain that gait control. And this you can see indicated in the graph by the increasing thickness in the black arrows, modeling a greater intercircuitry connectivity. And in this case, occasional fog occurs when processing demands exceed the combined capacity of the motor and the compensatory circuits. The limbic input, emotional arousal in the striatum, which is indicated by the red arrow, may even exacerbate this interference and make fog worse. The progression of nigrostriatal neurodegeneration, inherent of course to moderate Parkinson, heavily affects the processing across the motor circuits, increasing the dependency on compensatory circuits. And the risk for interference during gait becomes so much higher that it results in very regular episodes of freezing of gait and very severe walking impairments. In very advanced stages, the extranigral also neuropathology starts to affect processing across the compensatory circuits, and this results then in severe gait disability, very frequent freezing of gait, and many people are also bounded to a wheelchair in those later stages.